Hello, welcome to Unit 2, Lesson 7 with Professor Blackman. In this lesson, we're going to talk about finding equations of lines. So we'll find equation of lines given slope and y-intercept, given slope and a point, given 2 points, and then given an equation and a given point, we're going to find a line that has parallel or perpendicular to the equation given. Let's go ahead and get started. All right, so with equation, we can use the formula y equals mx plus b, where m is the given slope and b is your y-intercept. So we can quickly identify this as our m and this as our b. So when we plug that in, it would be y equals m, which is now negative 2/5 x plus b, which will be plus 4. And when we are given the slope and y-intercept, it's very quick, very easy. Plug in and you're done. So here we plug in y equals m, which is 0, x plus b, so that'd be minus 7. Now there's no reason to write 0x, so this would be y equals negative 7 when it's simplified. All right, let's look at some other types. Okay, so here we're given point slope, and for point slope, we're going to use this point slope formula that is here. So when we're given a point, we take the x1 and y1 and we plug it in to x1 here and y1 here. And the m we plug in here, and then after all that's plugged in, then we simplify. So let's take and identify that this is our m, this is our x1, and this is our y1. So when we plug that in, we get y minus our y1, which is 3, equals m, which is our 5, open that parenthesis, put an x, minus our x1, which is 4. And then we'll distribute that, and we get y minus 3 equals 5x minus 20. And then we need to move that 3 over. So we'll add the 3 here, and we get y equals 5x minus 17. All right, let's go ahead and look at the next one. So plug in y minus, and we can identify our x1, y1, and our m. So that's y minus 0, which is going to make it really easy when we need to simplify. Negative 2 x minus 8. Distribute that out, and y minus 0 will simplify to y equals negative 2x plus 16. And a good thing to do after working these problems is kind of plug in, and you can always check to make sure. Well, we know the slope is 5, and then when we plug in, we get 3 equals 5 times 4 minus 17. And that's 20 minus 17, so 3 equals 3. So it's got a slope of 5 here, and that point is on the line. Same thing over here. We can plug in 0 equals negative 2, x being 8 plus 16, and that's negative 16 plus 16. So that point is found on this line with a slope of negative 2. All right, let's go ahead and look at another example. All right, so here again, we're going to plug in. So using the formula that's given, y minus a negative 2 would become y plus 2 equals 2/3 x minus 1. Okay, so y plus 2 equals, distribute, we get 2/3 x minus 2/3. So now we need to subtract 2, and I need to subtract 2 here, but since our denominator is 3, I'm going to subtract 6 over 3. 6 divided by 3 is 2, so I'm adding and subtracting the same thing to both sides. So I get y equals 2/3 x minus 8/3. All right, let's look at the next one. y minus 3 equals negative 4/5 x minus 2. So that's y minus 3 equals negative 4/5 x, negative and negative is positive, 8/5. Okay, add 3 to both sides. And so the 3 I want to add with the denominator 15 is I'm going to add 15 over 5. 15 over 5 is 3, so I'm adding the same thing to both sides. And I get y equals negative 4/5 x plus 23 over 5. And again, you can plug these in. If you plug 1 in here, you get 2/3 minus 8/3. That'd be negative 6/3, which is the negative 2. So I know that's right. Plug in 2 here, you get negative 8 plus 23 would give you 15. 15 divided by 5 gives you the 3. So both of those work. Let's look at some more examples. All right, so here we are given 2 points. So with 2 points, we can't use point of slope yet because we don't have the slope. So what we need to do is use the slope of a line formula. Which is m equals y2 minus y1 over x2 minus x1. So it doesn't matter which one you make 0.1, which one you make 0.2, but as long as both points are coming from, so 1,4 is from one point and 5,6 is from the other point. So you could write this as also y1 minus y2 over x1 minus x2. And you end up with the same thing either way. So here we're going to first start by finding the slope. So we have 6 and 5 coming from the first point, minus minus, and 4, 1 coming from the first point. 6 minus 4 gives you 2. 5 minus 1 gives you 4. And so we end up with 1/2. So then we now have our m here, and we have our point. Now you can use either 1 and 4 or 5 and 6. It does not matter, but I'm going to go ahead and just use 1 and 4 because they're smaller numbers. So y minus y1, I'm going to choose 4, equals 1/2 x minus 1. If I chose to use 5, 6, I would put the 5 in here and the 6 in for the 1 and 4. Just make sure you're using the x and y from the same point. So now we get y minus 4 equals 1/2 x minus 1/2. So then add 4, add 8 over 2. 8 divided by 2 is 4, so I'm adding the same thing. So y equals 1/2 x plus 7 over 2. Okay, and so you can check both those points. If you plug in 1, you get 1/2 plus 7/2, which is 8/2, which is 4. If you plug in 5, half of 5 is 2.5. 2.5, or 5 over 2 plus 7 over 2 is 12 over 2, which gives you 6. So both those points are found in this line. All right, so again, start by looking at slope, and -3, -3, minus 2, minus 2. So that gives me -5 over -5, which is 1. If you did it the other way, you'd get 2 minus a -3, 2 minus a -3, and that gives you 5 over 5, which is equal to 1. So I'm just showing as long as you're taking from the same point, you get the same answer. So we get 1 either way. So now y minus, no, I don't want to plug in the negatives. I'm going to choose the 2's. 2 equals, because that's the easier number to plug in, x minus 2. So distributing a 1 just drops the parenthesis. Add 2 to both sides, and you get y equals x. Very easy to check. Y does equal x, and -3 equals -3, and y equals x, 2 equals 2. I know that both those points are found on this line. All right, let's look at our next example. All right, so here we are trying to create an equation of a line that is parallel to the given line. So in the previous examples, we had to use 2 points to find a slope. Now we're given an equation and we're using it to find parallel. So for parallel lines, what we do is when we look at their slope, they're the same. The slope of the first line is equal to the slope of the second line. So we start by taking this and putting it in slope-intercept form so we can identify the slope. So now I have 2y equals -x plus 6 divided by 2, and y equals -1/2 x plus 3. Now, a lot of students will make the mistake that they stop here, but this is only the first part. This is just helping us identify the slope that is -1/2. So now we use that and these points, x1, y1. So now we go y minus 7 equals -1/2 x minus 3. So I get y minus 7 equals -1/2 x distribute plus 3 over 2. So now I need to add 7 to this side, and I'm going to add 14 over 2. 14 divided by 2 is 7. So we're adding the same thing, but I'm getting my denominators to be equal. So then I have y equals -1/2 x plus 3 over 2 plus 14 over 2 would be 17 over 2. And if you plug in that 3/7, if you plug in 3 here, you get -3. 17 minus 3 is 14. 14 divided by 2 gives you 7. So that point is found in that line. All right, so over here, I'm going to switch the sides. So then it's 9y plus 2 equals 3x. 9y equals 3x minus 2. Divide everything by 9. And I get y equals 1/3 x minus 2/9. So I get my slope here as 1/3. So once I get that 1/3, I can plug in using my x1, y1. So that's y minus y1, which is 2, equals 1/3 x minus a -6, so x plus 6. Distribute, and you get y minus 2 equaling 1/3 x. 1/3 of 6 is 2. Add 2 to both sides, add 2 to both sides, and we get y equals 1/3 x plus 4. So we have a slope of 1/3. When we plug in the -6 here, that gives me -2, plus 4 gives me the 2 for here for the y. So that is our correct equation. Let's look at the next and final examples. All right, so for this one, we are doing perpendicular. So perpendicular lines have, when we compare their slopes, we take the first one and it is equal to the negative reciprocal of the second one. So as an example, like 3/4 becomes -4/3. So we need to start by finding out the slope of our given equation. And we get y equals -2x plus 3. So the slope of this one is -2. So a slope perpendicular would be 1/2. Negative becomes positive. 2 over 1 becomes 1 over 2. So then we can do y minus our y1, which is 5, equals 1/2 x minus 2. Y minus 5 equals 1/2 x minus 1. Half of 2 is 1. Add 5, and y equals 1/2 x plus 4. If you plug in the 2 there, you get half of 2 is 1, 1 plus 4 is 5. So that point is found on this line. Okay, so let's subtract the x. And negative 3y equals negative x plus 9. Divide by negative 3. And we get y equals 1/3 x minus 3. So the slope here is 1/3. So opposite reciprocal for the perpendicular slope, positive becomes negative. 1/3 becomes 3/1, which is 3. So when we plug in y minus y1, which is 1, equals m, which is negative 3, x minus 4. So y minus 1 equals negative 3x plus 12. Add 1, and we get y equals negative 3x plus 13. If you plug in the 4, you get negative 3 times 4, which is negative 12, plus 13 gives you the 1. So we know that that is in our right equation for perpendicular to the one given and that point that is also given. That's all I have for you today. Happy studying.